just conceptual stuff. So we might blow through the rest of it today, but we won't test tomorrow. In either way, don't act happy. That makes me want to give it tomorrow.
Okay, well,
I'm just
like,
kidding.
seriously, you're like, seriously.
Oh, my back. What did I do? No, it hurt when I woke up. What? You don't owe me anything. No one owes me anything besides to be quiet. Here we go. Generally, as temperature increases, so does the reaction rate. You should know that for the rest of your life. Typically, the hotter something is, the faster it happens. This is because K is temperature dependent. Oh, interesting. So you should know K is temperature dependent. So K is actually a constant that's different for every reaction and every temperature. So it's almost like it's never a constant. But whatever. Who cares? It's chemistry. All right. So the higher the temperature, the greater the value of K. Whatever. Pretty simple idea. Hello. Well, since you changed your hair, you're late more. Do you think they're related? Okay. Blondes just have more fun. I think that's a movie. It's a movie, I swear. Okay, the collision model, like that whole slide, that was that. Next, the collision model. What does it mean to collide? Yeah, you hit stuff. This is not hard. In chemical reactions, bonds are broken and new bonds are formed. Molecules can only react if they collide with each other. Oh, weird. So what we're saying is in order for A plus B to make AB, they have to literally come into contact. If they never do, nothing will ever happen. So it's kind of like being in a play in your first kiss. Just kidding. Oh,
It is a first case.
it is.
Some people have never gotten that one yet.
I know. You guys are juniors. You should work on that. All right. Anyway, furthermore, molecules must collide with the correct orientation and with enough energy to cause bond breakage and formation. Okay, you need to know this right here. They must collide, they must have enough energy, and they must be in the correct orientation. So this wonderful picture here is two Legos that are stuck together. Legos, they need to actually come into contact to stick together. They have to be in the right orientation, and you have to push them hard enough so that they stay together. All right, so the collision theory, once again, or the collision model, they must collide, they must be in the right orientation, and they must have enough energy to cause bond breakage. An easy example of this is when water self-ionizes. We know water's polar, so we have slightly positive and slightly negative charges. If another water molecule runs into itself, like another one, and they run into each other this way, where the O hits the O, usually nothing will really change. Yeah, but sometimes if the O, oh boy, this is all screwed up. Hold on. Okay. All right, now put it the other way, where an O runs into an H. Sometimes when this collision happens, the O attracts that H and you're left with OH minus, which you've heard of, and then H3O plus. We got hydroxide and hydronium. That does happen. That's how we get bases and acids. But if they don't collide in the right orientation, nothing would happen.
It feels like it's so basic, but it's like I feel like it's negative.
That they're 100% not related to each other. And they're really just named that way. A solution that has a lot of H plus and a little OH minus is an acid. A solution that has a little H plus and a lot of OH minus, that's a base. So the charges have nothing really to do with it. It's the balance of OH and H in relationship to each other. Yeah, pH is a measurement of the concentration of this. All right, anyway, moving on, we got activation energy. Another important thing that's just conceptual. Activation energy, in other words, there is a minimum amount of energy required for a reaction. That's the activation energy. Hey, will you go check and see if Rollins is done with my computer so I can have you break the law and put grades in? Yeah. Yeah. That's not, I mean, there's a gray area there. She's not a student. Yeah. Moving on. All right. In other words, there's a minimum amount of energy required for a reaction or activation energy. So the previous slide said there had to be enough energy. That barrier of energy is called the activation energy. Just as a ball cannot get over the hill if it does not roll up the hill with enough energy, a reaction cannot occur unless the molecules possess sufficient energy to get over the activation energy. Bennett? Bennett, are we okay? Okay. It's what? Yeah, it's exactly like a threshold. If you only hit the ball to here, it's going to come back every time. I'm sorry, but that's another day. All right, now, I appreciate all your opinions on golf. So reaction will look something like this. You got energy versus time. Nice job. This is endothermic. So in order for the reactants, to turn to products, you have to add, what am I doing? This is completely backwards. This is time. That's energy. You're going to draw these in a minute. Don't worry about this one. All right, so over time, I have to add energy to the reactants until they reach a certain height, and then they will produce products. The height is called the activation energy. All right, so this, almost every AP test, there is one of these, and they're really, really easy. So make sure you're pretty good at these. It is helpful to visualize energy changes throughout a process on a reaction coordinate diagram like this one. So this is for the rearrangement of methyl isonitrile. So the components of one of these graphs, make sure and label them. So I'll draw one all together here. Did we already do these in another one? How did Cooper Lloyd know it was endothermic so fast? Okay, you are the #1 AP classroom video watcher. I appreciate it. We have, okay. Okay, this is exo. You need to know how to draw every piece of this and whether it's endo or exo. So you would have time. It's the time that the reaction proceeds, and then you have energy. Wow, I feel like you paid attention. All right, this right here, this line, this represents the energy of the reactants. This represents the energy of the products. The height of this curve from where you started to the top of the hill is the activation energy. Okay. No, it's always from your reactants to the top. All right, then this bar from where you start to where you end would be your energy change. Now this one, since it's exo, it's your energy loss. If it was endo, it would be energy gain. Plug that in for me. Thanks for lunch. My group me? Oh, welcome to the world, Cooper Lloyd. All right, first Macy. Although Macy's going to be mad. They are not friends. No. Uh-huh. I can blame your mom, who I thought was my friend. Nothing.
I like knowing the
Track. I am a track coach. Minus initial energy. We've done this, chapter 5, if I remember right. So you just take your final and minus it. That'd be a negative value, and that's how we know it's an exo and the shape of the curve. Okay, there's one more point. I didn't leave much space for it. Products. This piece right here, I should have left a little spot for a star on the very top of the curve. It's called the activated complex. That would suck. Oh, well, if he was pulled out, that usually means like at least he's alive. All right, activated complex. Activated complex is like when you like tried to start a fire and then finally it's burning on its own. There's no more work involved. The reaction will happen. So like lighting that fire, you watch all those Survivor episodes. They're like twirling those sticks forever. Like, come on. They're trying to get all of this in, and then it finally sparks, and they blow in that coconut husk, and woof, the rest is free, right? Oh, during COVID, my sons and I, we had to watch 1,000 hours of Survivor. We got through the first 26 seasons or something like that. Okay, moving on. Don't worry about it. The activated complex, the reaction will happen now and you can't really stop it. You all right with that? Okay, make sure you understand those things. Oh, hey, look right here. It's on the test. All right, so, I don't know, do I need to go back? I heard some disturbance in the force. This line is always representing energy. Okay, then a catalyst, you can add it now if you want, it's going to come up later, but a catalyst, the energy would start the same, the energy of reactants, but our activation energy would be much smaller. So we get to the products much quicker. The total change in energy is the same. This should be flat. It's ugly, but that should be flat. So a catalyst lowers the activation energy by changing the pathway that the reaction happens in. That's a little bit weird, but we're going to talk about that here in a minute. Tons of times. Question? No, not yet. I'll give a couple days. Very, very often, even on AP tests, you'll see this incorrectly labeled, and don't argue with anyone, but oftentimes it just looks like this. Like the bump is lower, but it still is the same here. Don't get mad if it does that. It's slightly incorrect, but it's good enough. Okay, it lowers the activation energy. So on this graph, it makes the hill smaller. And if you don't have to go over a big hill, the reaction can happen a lot faster. Now, you ever heard of preservatives in your food? They are anti-catalysts. And instead of lowering the activation energy, they like skyrocket it. Salt, vinegar, I don't know. They're all the things you read on my Mountain Dew bottles.
Why would you want it to get for? I'm trying to think how that would like make sense that you want a higher activation. Because you don't want to.
You want to slow the reaction.
Once you eat it, it's just to preserve it.
Yeah. So when I was a kid, I worked at a grocery store, and my favorite thing to buy was a lasagna that wasn't even refrigerated. Hey, anyway, that was like the best snack. You would just go to this one shelf, and every time I'd get it, I'm like, I don't know why I love this, because every lasagna ever should be refrigerated. Then you microwave it and it was delicioso. Wait, that's Spanish. Delicioso. That's Italian. Don't judge me. It was a joke. Anyway, so a preservative slows the rate by giving it a very high activation energy. Okay, moving on. Oh, so this is a typical question you'll see on the AP test. The answer is right there in front of you. Bah, there I go. I don't know. We'll see. Next, here we go. Draw this. Methane reacts with oxygen in a simple combustion reaction. The activation energy is 22 kilojoules per mole, and the reaction releases 80 kilojoules per mole. Draw the reaction coordinate diagram. Ooh. Well, it's definitely exothermic. Okay, where would you start the energy? It doesn't matter is the answer. You should start it above 80. That's all that matters. You can pick your start. That's arbitrary. But you want it to be at least above 80 because you don't want your graph to go through 0. You with me? Thanks, Grace. You always have my back. Thank you, Fabian. You'll be with me all day. Do we really want to go to Nielsen's again? I couldn't care. I'm not a foodie like Jesse. I could go to Burger King and be happy. I just ate 4 pieces of pizza, 2 breadsticks, and a huge Mountain Dew.
Do you guys know that when I had driver's ed, I accidentally got Jesse in trouble?
Oh, you were the one, huh?
I was the Krispy Kreme guy.
It was you.
That was me. Well, apparently, it is not good driver's ed when you ask Jesse if on your 15-minute break between the 2 hours, if you can go to the drive-thru and get Krispy Kreme. Why? Because apparently it's unhealthy to buy 3 boxes of Krispy Kreme. And then be gone by the next time I saw Jesse.
Last time that we went didn't you pay for the car because you thought that we were behind you?
Yeah, Jesse's like, we got the car behind us.
How much did it cost? Like
It was a ton of money. What should this number be right here?
something over 80.
All right, let's call it 100 because that's easy math. You should label it, yes. What would this number be up here? 122. What would this number be down here? This is where kids go wrong. It's 20. Way to not be normal chemistry students. Why is it 20 and not? It's from the start to the end, not from the height of the activation energy.
Wait, so the activation energy is on top of whatever it is.
Yeah. It's a bird. Say that. Yeah, we don't include it like we do. It goes up 22, but we don't, the overall change, we completely ignore how high it went on the activation energy.
So we could put like 25 and then go up 22.
You wouldn't do 25 because then you'd be a negative value under here. 25 minus 80.
What that's like the lowest activation?
Say that again.
What like combustible material has like the lowest activation?
I don't know.
What's like how low?
I don't know.
I
Sorry.
want to know who ratted me out. Who ratted me out?
It was either your mom or the mom you drove with. It was one of the parents.
It wasn't my mom.
It was probably the other one then.
Because I didn't tell my mom. She didn't see the Krispy Kreme. What happened? So we went on our drive, we went up through Logan. We were about to go up through the canyon, but we took our break because we were
2, 1. Here we go. Reaction mechanisms. This is a very important part. The sequence of events that describes the actual process, don't talk, by which reactants become products is called the reaction mechanism. So if, for example, we had A plus B plus C went to A, B, C, the reaction mechanism will say something like, all right, we know this happens, but really, first off, A reacted with B to make AB, and then second off, AB reacted with C to form A, B, C. Well, they could. I was just writing an example.
So you're just like showing exactly what you did to get there.
Right. So instead of saying I'm on the second floor, I would now tell you each step I took to go from the first floor to the second floor. That's all. Don't bend it.
Why would
That
this
would
be,
be hilarious to people.
why would this be useful?
You'll find out, my little amigos. You will definitely find out. Sorry. Oh, don't. I thought he was complaining I used the term amigos. I'm like, sorry, Fabian. I was-
I want to write a formal complaint to Davis's dad about Rade Villa.
I'll text him. Okay, here we go. Next. Oh, sorry. What was so groundbreaking? Hurry.
Anyone extremely exhausted today?
Nope. I'm super hyped. I'm worried we're getting blown out tonight. No. Oh, never mind. You can stay home. Yeah. All right. Can I move on, Judah? All right. Murray, good? Okay, moving on. Reactions may occur all at once through several steps. Each of these processes is known as an elementary reaction or elementary process. So coming back here, and I'll come back, don't worry. This would be the overall reaction, and these would be the two elementary steps. That's the vocab.
They call it elementary step reaction.
Step, reaction, process, all three are the same. All right. So it's literally like I said before, we're just talking about the steps you go up to instead of just looking at what floor you're on and what floor you're on now. All right. An elementary reaction, elementary process, elementary step. And you'll see why it matters. It's actually really helpful to you. And it relates to what we've been doing. All right. I'm moving on. All right. Now here's some words that are new, but if you're all right with uni and bi, you'll be fine. Ter just means the rest. So a unimolecular process means that one thing happens. You have A and it just goes to products. All right. Bi means at least two things are now involved in the reaction. All right. Now, this is, it's not tricky, but it could be two of the same things, like Cl plus Cl goes to Cl2. That's diatomic chlorine. This happens. All right. That would be like this example. Or A plus B could be Li plus Cl goes to LiCl. Okay. I know this is not balanced, but this would be like an elementary step. I guess we're never going to go past ter. Ter is 3. All right. Now, here's what's cool. If we can determine it was a unimolecular where A just goes to products, we can tell that the rate law is first order. And that would make sense because the rate would only depend on this stuff, one single thing doing what it does. That's like a decomposition reaction. All right. Now, if it's a bimolecular of the two of the same things, whoops, I just better erase here. So A plus A, we've configured this out through this simple process we're going to learn. Then that would tell me, since two A's were involved, that the rate was equal to A squared. It had an A at times an A. Go ahead.
You're just saying that you can figure out what like the rate was without even having to do all that stuff.
But if you have the reaction mechanism, you can find it every time. because you're not always given the mechanism. And we can't figure out the mechanism. Those are done through experimentation. All right. Then if it's a bimolecular with two separate substances, it's still second order because there's two things involved, but it's first order with each independent thing. All right, then termolecular, it could be three of the exact same things coming together. And these are rare, by the way, because it requires A to run into A, which is running into A. Like all three of them have to hit the exact same moment of time. So these are really rare. Ozone, not really, because it's O2 plus an O. So these two came together first and then gained that. I know that seems weird. It's the elementary steps.
So it'd be a bimolecular, which is then going into another bimolecular.
Yep. Okay, so this is a thing. I shouldn't cross it out, but it's really rare. These are more common, and they're still pretty rare. But AAB would be A2 and B. The exponent is just the number of things you see in the reaction. And then A plus B plus C, and that's just ABC. These are absolutely imperative that you know. These are nice to know, but that's about it. Oh, I thought my wife was going to help me, but she didn't. Well, we got some decisions to make in life, and as any good man does, I said you have to make the decision.
Are these like extremely personal decisions, or is this
Oh,
like?
it's none of your business decisions if that's what you're wondering.
Sorry, you're not
It's life changing is what it is though. All right. Yeah, I got the first kiss. I got that out of the way a long time ago. Okay, here we go. Yes, Judah.
You can make synthetic ozone.
No, but we can make ozone. But yeah, we make ozone. I worked in a water plant that used ozone to sterilize spring water. This doesn't quite work that way. Like it can, but it takes time, like years for it to go up and replace. And also ozone at ground levels is extremely dangerous. I read an article just yesterday. It said, yeah, COVID's bad, but let's be real. 9 million people a year on our planet die from air pollution. And one of the main things that kills them is ozone. So we don't want it at level. There you go. All right. Anyway, I'm not arguing it. The only problem, well, I'm not going to argue. Okay, here we go. All right, now I need you to focus. This is important. We're out here at 110, right? Okay. A multi-step mechanism. This is important. In a multi-step process, like these reaction mechanisms, usually one of the steps is slower than all the rest. All right, so like I put in a shed this summer, sort of. So I had to dig a hole 20 by 14. I had to dig a hole. Then I had to put gravel in. All right. Then I had to order cement, get it poured in. And then I ordered a shed because I am definitely not a builder. Can't even draw the right shape. Right. I bought a shed and had it delivered and put on top. Any idea what the slowest of all of it was? No. The shed. It took 11 weeks to get the shed from order to delivered. Turns out everyone got their federal stimulus and thought, I'm going to buy a shed. They're like, we've never been this way. We're sorry, but we'll get it to you sometime by the end of the year. I'm like, it's August. Anyway, so it took me like 2 weeks to dig and lay gravel and get cement. And that sounds like a lot, but really, it was the 11 weeks that determined how long this took. In chemistry, the slowest step is the one that determines the rate. It's like when you're on a 4x4 relay and everyone runs a one flat, but someone drops a 130. You lost. It doesn't matter. You got a sucky fourth leg. All right. The slow one ruins it for everybody. No, I have so many personal experiences. This is a pet peeve.
We don't want to talk about
No, we're talking about it right now. There's a racing track called the Medley. I hate it. I hate it because I am a sprint coach. All right, you don't care. The Medley. I'm on my way. I'm on my way. The Medley is the 200, a 200, a 400, and an 800. I coach these three people. Rollins coaches this loser. Hey, it doesn't matter how fast my three people get the baton around. This person lays down a 230. Does it matter if my 200 runner PR'd by half a second? No.
because that's actually a really important runner.
Yeah, they got rid of the medley because everyone knows it really only depends on your 800 runner.
Wait, so do you blame it all on Rollins every time?
No, I can't do that. I'm a human that's professional, but I know it was him. One time we're at state, and at state in 5A, you have to do prelims on this race and then run it again the next day. You have to be in the top 9. And he took a gamble. And I put in my 2 best, not breast, that was awkward, sprinters. I put them both in, and we put in our best 400 runner. And he's like, we'll qualify for finals. I'm going to run our second best 800 runner. So we come around after the first 2 laps, which are these people, we're in first place. After this person, we were in 9th place.
Whoa, but hey, it was a good gamble.
Top 8
Oh, I
made
think
it.
top 9.
It is the top 9, but it's a 2-heat final. One team from the previous heat beat us. And he was pumped. He's like, oh, wow, we barely made it. And I'm like, we barely did it, you loser. I was so mad.
Isn't the 400 one of the hardest things to run?
No, dude, I ran it. I loved it. It was a piece of cake. Moving on. Okay. Who lives in Perry? All right. Okay. What? You travel to school. What determines how fast you get here?
The light.
The light. You can speed like 40. No, you shouldn't, but you could in that 25, and you probably have. But if you hit the red light, the person that did 25 just rolls up behind you laughing. Right. So the light is the slow step. You with me? The light's the slow step. Okay, in chemistry. Whatever. This is not the right thing. It's good. Whatever. The order of the reaction can give you clues about the mechanism, and the mechanism can give you the order of the reaction. Okay, just keep going with me. Don't worry about that yet. Is there not a slide on just the slow step? Okay, fine. I'll just say it out loud. There are 2 types of steps. There's a slow and there's a fast. The slow is what we're going to look for. And then I'll talk through this process. It's really easy after like the 2nd or 3rd example. Okay? If we look at the order and we find the slow step, we can figure crap out pretty easy. So here is an example. This tells me that the first step is slow. The problem will either tell me which is slow or ask me which is slow. And if it tells me, I can find the overall reaction. If it asks, it will give me the overall reaction. So it says, this is the rules. But what we're trying to do, we're trying to find what the rate law is for this reaction. All right, so what I do is I'm going to look for the slow step first. Anything after the slow step, I'm going to cross out for right now. Okay, now it's sort of important, but for right now, I'm going to look at the slow and anything that came before it, but nothing that comes after it. Just stick with me here. In the slow step, I then look at my reactants. My reactants are A2 plus B2. So that'd be like O2 and Cl2 or something like that. You with me? Or it could be a catalyst, or it's just what we call an intermediate step or an intermediate. All right, so those would be gone, and we'll learn more of those when we go to the next example. So what we do now is we know that our rate is equal to K. That part we always know, right? And then I put every reactant that I have in a bracket. And then I put the number of how many there are as the exponent. Yes, never these. So by looking at this and knowing that the slow step is the first, I can tell you that it's first order with A2 and B2, and that the rate law is rate equals K times this.
So if it was split, then it'd be second.
Okay, so let's talk about that. We will look. You all right so far?
Yeah.
If this is fast and this is slow, now I look at everything involved and I cross out any intermediates. That means it's something produced and consumed. And then I'd look at just the reactants. And now I would have how many A2s? So A2 would be a square and B2 would be a 1. I don't worry about the products, but I use the products to get rid of intermediate substances. That's not that awful, right? Once we know these, then we could do all sorts of things because we have the integrated rate laws and say, all right, well, if the original concentration of A was this, what's the concentration of A at this specific time? We can go after it. We can solve for the concentrations. It could give us concentrations. We could solve for K. Like we could go all sorts of places with this. Okay, so here we go. Consider the following. This is ozone decomposing. All right, we have slow here. You want to do it on your own? All right, you have 30 seconds.
Done.
All right, good. We know rate equals K. I'll get you that far. I 100% guarantee you did it wrong. I hope.
I hope you do. I felt super confident.
All right, so that's been 30 seconds. So this is slow, so I don't need to worry about anything after. I account for all of the reactants except for I check for any intermediates, which is something both used and produced. And I'm left with just these two. They are the same thing. So it's O3, and how many are there? 2.
High five, Leslie. We did it.
So you would now know that this, just from this order, you would know that the rate is equal to K O3 to the second. It's second order with respect to ozone.
So if on the test, that later on I pick questions with that formula and then just tell us the rate law.
It'd be something like this and ask for the rate law. Yeah, sure. I got a ton of them. Today is Tuesday. The bell does ring in 27 seconds is the only problem. It can have whatever you want it to have, my friend.
Rate equals KO3. No. KO3 1. And then O1 as well.
Okay, we will pick this up tomorrow. We are roughly, we're like 3 slides away from being done. So plan on the test Thursday. Yep. What? You can leave it there. It's okay. Thank you, though.